So children, we have in this video determination of order of reaction. How can we determine the order of a reaction? Suppose the reaction is 2A plus B arrow C and D, and this is the data that we are having. We are having 4 experiments. Suppose in experiment number 1, concentration of A 0.1 moles per liter, concentration of B is 0.1 moles per liter, and initial rate of formation of D, which is we can say rate of reaction is 6.0 into 10 to the power minus 3 moles per liter per minute. Similarly, in experiment number 2, concentration of A is 0.3, concentration of B is 0.2, and initial rate of formation of D is 7.2 into 10 to the power minus 2 moles per liter per minute. So like that, these 4 experiments are there. Now, let me tell you how can we determine the initial rate of experimental. We make a plot of concentration of D versus time, and since D is the product, initially it at time 0 concentration of D will also be 0, and then it is going to increase. So we will get maybe points like this. Points like this, and at t tends to 0, we have to draw the tangent. We have to get the slope of this tangent, and this slope of the tangent will give us the initial rate of formation of D. Initial rate means at time t equal to 0. Okay, now suppose the order of this reaction is the rate law expression for this is R is equal to K A to the power alpha and B to the power beta. Suppose this is the order of this is the rate law expression. So it means it is alpha order with respect to A and beta order with respect to B. So we can write 4 equations based on 4 experiments. So first we have initial rate is 6.0 into 10 to the power minus 3. A, concentration of A is 0.1 to the power alpha, concentration of B is also 0.1 to the power beta. So this is equation number 1. Next, 7.2 into 10 to the power minus 2. So rate constant, and now it is 0.3 to the power alpha, 0.2 to the power beta, equation number 2. So likewise 2.88 into 10 to the power minus 1 is equal to K 0.3 to the power alpha, 0.4 to the power beta. This is equation number 3. And finally we have 2.40 into 10 to the power minus 2 equal to K 0.4 to the power alpha, 0.1 to the power beta. This is equation number 4. So these 4 equations we are having, and now what we have to do, we will divide one equation by the other. We divide in such a way that either alpha or beta, any one of them gets cancelled out. Okay, suppose let us do this thing. Suppose we divide. Suppose we divide 3 by 2. If we divide 3 by 2, so equation 3 divided by equation 1 equation 3 divided by equation 2. So on dividing equation 3 by equation 2, this 0.3 to the power alpha, 0.3 to the power alpha will get cancelled, kk will get cancelled, and so let us write down what we get. We get 2.88 into 10 to the power minus 1 by 7.2 into 10 to the power minus 2, and here we will get 0.4 by 0.2 to the power beta. This will be getting. That means this one will be 2 to the power beta, and this one on simplifying, it will be your I think it will be 4 times 4. In the next line we can write this 4 we can write as 2 square 2 to the power beta. So now since base here also and here also it is 2, so naturally powers will be same, therefore we can write beta equal to 2. So order with respect to B we have got. Now to find the value of alpha, what we do is we divide in such a way that beta get cancelled. So suppose now let us take equation 1 and equation 4 and let us divide equation 4 by equation 1. Equation 4 divided by equation 1. If you divide equation 4 by equation 1, so beta get cancelled and kk get cancelled, and so we are having your 2.4 into 10 to the power minus 2 by 6.0 into 10 to the power minus 3 equal to, and here it will be 0.4 divided by 0.1, 0.4 divided by 0.1 to the power alpha. So this on simplifying we get this one, if it goes it will be 10 to the power 3, so 10 means 24, so it will be 4 times. So again 4 here, and it will be 4 to the power alpha. Now 4 can be written as 4 to the power 1, this 4 to the power alpha. So on comparing we are getting therefore alpha equal to 1. So order with respect to A is 1. So the rate law expression that we are trying to find out, it will be R is equal to K A to the power 1 B to the power 2. So this is the rate law expression, and you know, you may also be asked to find out the rate of the reaction, you know, at when concentration of A and B will be given, say some other concentration. So it's very easy. We just put the value of A and B here, and now your we can also find the value of rate constant. We can also find the value of rate constant. How we can find the value of rate constant is, suppose a rate. Suppose we got the value of alpha and beta, okay, and by using any one equation, we can get the value of rate constant. Any one equation, by using any one equation, we can find the value of rate constant. And if we are asked to find rate of the reaction at certain other concentration, that we can find out by using this equation. So like this type of questions, it comes in exam. Okay, determination of order of reaction. Okay. Now, this is in addition to, what we had already discussed in one of the video, that a reaction, whether it is first order or not, that we can understand by graphical plot. Likewise, a reaction, if it is zero order or not, that also we had discussed how to understand by graphical plot.